Hi. Hi. Is there any problems? My name is Ryan.
Oh, nice to meet you.
Nice to meet you.
I'm Rami.
Rami, nice to meet you.
I'm in Math 275 right now.
275.
And I'm having trouble with this problem here. They want me to solve this differential equation. It's 2t dy dt equals 6y.
And you have that 2t.
I don't even know where to start with this kind of problem.
261. So did your professor tell you about anything how to solve differential equations? So any methods?
Yeah, I think we learned about like integrating factor.
Integrating factor. That's one.
Separation.
Separation.
And what else for first order?
Bernoulli's.
I think, yeah.
Okay, so actually the first two are for the first order equations. However, the Bernoulli's is not for the first order. So let me give you a little bit of advice on there. Is that when you are learning like things like differential equations, it's all about remember the methods of solving different kinds of equations. Once you remember how to do that, it's really easy to learn this course. So Bernoulli, so for the Bernoulli equations is for higher order. Like if we have 6y squared or something, it's non-linear equations.
Oh yeah, I just saw it in the textbook. I thought it might work here, but so which one should I pick?
Okay, so maybe you should pick the first or the second one. Whether you can multiply it by a common factor or you can try separation.
So I think I might be able to move these to different sides to separate it.
Yeah.
So okay, I'm gonna multiply by dt on both sides.
Yes.
And dy here. So I have 2t dy equals 6y dt.
Yes.
And then I want to integrate both sides, right?
Yes. That's what we want.
And
then
how do I integrate 1 over y or 1 over t?
Okay, so here's also something to remember about it, is that if we are integrating a fraction and we have the unknowns and on the denominator, and it come out to be a natural log. So in here for this t, for this y, it's gonna be turns out to be a 2 ln y, and on the other side it's gonna be a ln, the 6 ln t, and don't forget the constants. It's like we'll have a constant here and a constant on the other side. However, if we cancel them out, there's only come out only with one constant. We can write it on the other side. So let me write it down. It's gonna be like 2 ln y with absolute value, don't forget it, equals to 6 times of ln t with absolute value plus c. So that gives us a form of equation, and here how you simplify it.
Okay, so that's derivative, integral of 1 over y is natural log of absolute value of y.
Yes.
Okay. And then you said we put the c on one side. So my professor taught us to put absolute values on our natural logs. But I don't know why do we do that? Okay,
the reason why we have to do that is because for the natural log or any log, it's like it only accepts a value that is bigger than 0. So that's why we have to put absolute value to guarantee that we get a bigger, we get a non-negative number for that.
The domain of natural log, it's 0 to infinity, right? Okay.
Okay, actually it doesn't include the 0.
Oh,
so yeah, this absolute value actually just prevents all the negative ones, but it doesn't prevent 0 though.
Okay.
So
absolute values go here.
Yeah.
Because y is greater than 0 and t is greater than 0. And then we put a constant. And then y we divide by the 2.
Yeah.
And then y is equal to e to all of this over 2. And
it seems that you're going pretty far from here.
Okay, so
Yeah.
I think I got my general case.
Yes.
And now, so this is the problem. It wants a specific answer. How do I find the particular solution?
Okay, so according to the definition, if we want to find a particular solution for a differential equation, so the first order and linear differential equation, we need one initial condition for that. And here, as the question gave us, it's 2 and -8. So,
Right.
yeah. So that is what we call the initial condition. So what we do is basically we just plug in those this order pair and find out what C is. And in this case, let's see what you get. If
So I want to make my T 2,
yeah.
and then my Y -8.
Yes, exactly.
And then solve for this. Okay, cubed. So my C is -1.
Exactly.
Right. So then, once I found my C, do I want to plug it back into the equation and get this?
Yes, that's what we want, and that is what we call a unique solution for this one. So it's like, it's pretty weird that the solution is a function, but that is what we are here for the differential equations, because the solution is still a function, and that is what we call a unique solution, because it's a very unique, it's a unique function. It's like, it's just this one function. If we change something else, it's going to turn out to be different.
So because it's unique, that means it's our only solution?
Actually, here's another general, that is what general solutions for, is that it provides all the possibilities for that. We adding a C here, it is because whatever it changes, it doesn't affect the derivative of that. If we have any changes in C, the derivative also follows in scale, so it still comes out the same thing.
So this says that when they talk about existence and uniqueness, our general solution tells us that the solution exists, and it's -infinity to infinity. And then if we want the specific solution, we plug this in, right? The initial condition, y2 equals -8. Okay.
Yeah.
So then our final answer would be y equals -t
cubed. Yeah. Exactly.
Okay.
Okay.
Man, I have a test next week. I need to study this more, I think.
Yeah, don't worry about it. I mean, just remember about all the key stuff in studying differential equations. Don't use the wrong equations, the wrong methods, and I think you make it. And good luck on the test.
All right, thank you, man. I appreciate it.
No worries.
Thanks.